So a flexible image can do quite a bit in terms of shape. The probably most important aspect is just the ability to round off the corners like so. So we can apply chamfer or roundness, and we can do that all at once by scrubbing on the chamfer label, or we can do that individually on a per corner basis. Now we have this normalize toggle here, and what normalize means is that no one corner can consume more than half the image. If we toggle that off, then we can keep going. And if we have normalize on and we apply a chamfer to all four corners, we eventually get to a perfect circle. With it off, it keeps going like so. To go along with chamfer, we have this concavity setting, where at 0 we have convex corners, at 1 we have flat corners, and at 2 we have more concave or scalloped corners. And again, like before, we could do this on a per corner basis. We have a toggle that is for squircles, and when we enable this, concavity turns into smoothing, which is the term that Canva uses. Another way to think about it would be that as smoothing approaches 1, the image becomes more squircly or more squarish and less circular. And we can change how much we want to apply that, and we can do that on a per corner basis as well. Now let's zero this all out, and moving on, let's go from top to bottom here. We have stroke, and we can have the origin of the stroke be from the center, like so. We could also have it coming in and out from the perimeter. We could also apply an outline, and if we apply, say, a 20-point outline, then we can have stroke origin outline, and at 0 we just have the outline. If we were to put 10 points, then we'd have a 20-point outline with a 10-point interior, and so on. These units tend to be in canvas units when they aren't from 0 to 1. So let's take that off for now, and we'll take off our outline. And moving down, we have feather mode, or you could think of this as softness or fall off. So to demonstrate this, I'm going to clone my flexible image. I'm going to make the clone red. I'm going to take off all of its softness and take off its chamfer and throw it behind. So here we can sort of see we have a direction inwards, outwards, or bidirectional. And you can see if we go inwards that we soften into the shape. If we soften outwards, we soften out of the shape. And inwards, or sort of bidirectional, it's a mix of both. So we're softening half in and half out. And this can be important if we zoom in here, just in terms of lining everything up if you're concerned about pixel accuracy. So with no softening at all, we have these jaggies on the corners, but everything is perfectly pixel aligned. If we add, say, 1 unit of softness, then we see that we have nice smooth corners, but we're also extending a little bit beyond the old pixel boundary because we're softening in both directions. If we went inwards, then we'd only be softening inwards, but we can start to see the background peeking through a little bit where we are more transparent. So in general, any value between 0.5 and 2 tends to work good for softening, but by default we keep that at 1. Now let's disable our background here, and we'll move on. We have size modifier, which is basically just taking the width and height of the rect and being able to or of the element and being able to modify it in a transform independent way. And transform independent means if we had a child here, and again we'll make it red, and let's just put it into this stretch transform mode. So on the parent, if we change the width or we change the height, we're also changing the width and height of the child element. But if we do that with size modifier, the child element stays the same. So this could be useful when you want to position things with an offset, but not have the children offset, or when you want to do animation that doesn't affect children. We have this aspect correction toggle here, and all that means is if, say, for example, I had 1600 width and 800 height, and if I apply a size modifier, actually let's zero those out. If we apply a size modifier, we're growing by 100 units here, both horizontally and vertically. But if we have aspect correction, then we only grow 50 units vertically, because our vertical rect is only half the size of our horizontal one. So it basically just means as we expand and we have the same values in both x and y, that the aspect ratio of the element remains the same. And again, like always, we can do this on a per axis basis. So let's get rid of that for now, and we will move that back to 800. So we have something similar with offset, and that just means we can offset the element without affecting the child. Similar with rotation, we can do the same. Doesn't affect the child. Now with rotation, we have something else that's really cool. Let's disable the child, and we'll re-enable this guy back down here, and let's get rid of our chamfer. So as we rotate, and you look at that background element peeking through, we can see that the corners end up expanding beyond the boundary of the original rect, right? And that's just sort of the way the geometry works. But we could also do this fit original rect toggle that will automatically resize things so that we don't expand beyond that boundary. So this is handy when you have elements that are all aligned and laid out in a specific way, and you want to do a rotation, and you want that element to stay inside of its specific area. Say if you want a 45-degree rotation. Moving on, we have this UV rect property, and this is a little bit more advanced, but let's say if we add some chamfer and we add some stroke, and we get like this circle with this hollow circle, right? And let's say we wanted to have like an arch or a rainbow. We could take the UV rect and say move that down to 0.5, and now we have an arch. And then if we wanted to, we could offset that. And there you go. But this is very handy in multiple data mode, where you can define different quads with different anchorings. So you could potentially chain different elements together. You can make like something that goes down this way and then back up that way. So it's one way to get more interesting shapes. Next, we have this skew section, and this is one of the sections that really makes flexible image stand out. And we'll get rid of this background for now. But the skew is basically saying we can pick an edge, top, bottom, left, or right. We can pick a position along that edge, and then we can basically have a certain amount of collapse. So we could create like a triangle like so, just by doing a full collapse, or we could create like a trapezoid. With this toggle, we can do a parallelogram where we collapse the opposite edge inversely. And we can see how that works here. So lots of different things you can do with this. And one cool thing here is, let's say we have a parallelogram, we can apply chamfer if we want, but if we collapse it onto a triangle, now we have 3 different corners we can apply chamfer to instead of 4. So what we also have here is this relative toggle, or which can also be absolute. So let's say we just go like that, and we collapse 0.5. We collapse halfway, right? And if we change the size of the element, then it remains half the element. So that's so imagine you want to have like a bar, and then you want to have with segments, and you want to have another segment over here, and segments can have different length, and that wouldn't really work that well for that. But we can go to absolute, and then you use a certain amount of units. So 400 units would be the same as the half that we had before. And now, as we change the width, which we could do there, or we can do with our size modifier here, we can see that it remains the same. So we can change the size, and that angle is going to stay constant. So let's get rid of that for now, or we'll just do that. Moving on to our last setting is the cutout setting. And this is an interesting one. So by default, when you enable a section, it sort of cuts out that entire section. We're cutting out the entire left section, and we're cutting out sort of from 0, which means from the far edge. If we change this to 10, we'd be cutting out from 10 units from the edge, right? So we're cutting out from here to the center. If we put right on and then put 10, now we're cutting out from here to the center on that side. So we have the entire area inside that's cut out. So let's do 10 units and 10 units like this, both horizontal and vertical with top. Now we have two different rules, or and, and we can see how these work. Or means that we cut out if we touch it horizontally or vertically. And means we need to touch it both horizontally and vertically in order to cut out. So, for example, if we removed top, then no matter what we do with left here, we don't cut out anything because we need something else to come in at the top to cut out. So we can cut out like a very specific area. Now here's where this can get really cool, is if we say made this 150 points on all 4 of these, change that to or, and now we just have like 4 different squares. Now imagine that we add an outline. And now if we do outline only here, now we're only cutting out the outline, so we get a little bit of almost a reticle effect, and we can add a little bit of chamfer, and that's a sort of cool effect there. We could also invert that, and now we're cutting out the inverse. So that could be really handy when used with outline especially. So that is it for the shape section in Flexible Image. And yeah, there's quite a lot that you can do with this, especially with the collapse here. I hope you enjoyed that.